Hello. I haven't been here in about 50 generations. My DNA has been waiting for a long time. I'm pretty sure that people ask all the time, why do you have red hair on your beard and blonde hair? And I always blame Scandinavia. So it's cool to be here. It feels like I'm at home. I started a project in January. I quit my job. Last year I did mobile web apps, used a lot of Xcode and Eclipse. And those things are not fun. And I was like, I need to look for something new. It was right around the holidays. I was screwing around with stuff. And so I decided to get into 3D programming. The project I started is called Voxel.js. And it's on Twitter. You can follow it to keep up to date with things. And let me show you. The slides are also online if you want to play around with the demos during or after. Go for it. This is a little presentation software that I put together last week. Here's a voxel Viking in the game, because we are here in home of the Vikings. And there's a voxelized character here that I'm playing with, and it's a third person or first person kind of Minecraft kind of engine. And what you see here is the result of a lot of open source work from a lot of people over the last 5.5 months. And each one of these blocks is a slide, so I'm going to get going with it, because there are a lot of fun demos to play with. And so the first thing that got me really excited about the potential is this demo. This is a blog post on this blog called 0fps.wordpress.com. I later found out that it's a computational geometry PhD named Mykola Lysenko. And he goes to school in the United States and works at a 3D printing company where he uses quantum field theory to do paraplegic arm reconstruction. It's insane. The guy is the most smart person I've ever had contact with, and he contributes modules to Voxel.js now. But before there were any modules in Voxel.js, he wrote this awesome demo. And there's a couple demos on this page. And the thing that blew my mind was he was talking here in this blog post about how does Minecraft actually render. When you play Minecraft underlying in the data structure and the 3D rendering, how does it work? And he wrote this in-browser demo using Three.js. And if I turn off the outside, you can see that this is a bunch of voxels, and there's a lot of interior vertices that you don't see when you're playing the game because the surface is opaque. You can't see the interior stuff. So he wrote an algorithm that can remove interior faces and make it much more optimized to render. And basically at that point, I was like, cool, it's possible to do this stuff in WebGL. It's possible to do in a web browser. Where do I go from there? So I quickly found Three.js, which is Mr. Doob, who was mentioned earlier, prolific demo scene guy who maintains this project. This has basically everything that's possible in WebGL he has written, and he's turned into a pretty big framework. And I'm not the kind of developer who can start doing 3D and write my own 3D engine immediately. This is actually, I started 3D programming in January. I hadn't done any before it. So Three.js has been awesome from a framework perspective. And the other first thing that I did was copy code from other people. So GitHub, this is actually, GitHub search is a lot better now, but if you go to GitHub and you search for Minecraft and you filter by JavaScript, you'll see that there are hundreds of, 223 repositories that are Minecraft and JavaScript related. Some of that stuff isn't rendering Minecraft in the browser. Some of it is like plugins for Minecraft that, all sorts of stuff. But a lot of them I found out, I have a Minecraft folder on my computer, and it has all of these repos that I cloned. And so here there's 69, 60 plus repos that I cloned from GitHub that looked like they were somebody trying to write a Minecraft renderer in the browser. I never saw one that was super reusable. All of them seemed like what I like to call genius programmer code, which is really, 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 really smart, but is basically, unless you're the person who wrote it, you'll never understand what's going on. And the thing that I like about Node and NPM is that all the modules are small, simple. They don't try to do more than they should, and that means that it's really easy to get involved. So I read through the source code of all of these. It took like a week. All I did was try to wrap my head around, what was the approach? How did they do it? What was how did they differ from that rendering thing that I saw on Mykola's blog? And once I got through all of that stuff, I kind of had an idea of, okay, here's where some of them had limitations. Here's where some of them really excelled. I combined them all into an open source project called Voxel.js. And the Voxel.js project now, if the website's voxel-js.com, you can go there and look at what we've built as a community. I got a lot of help from my roommate, Substack, who has, I think, some of the most JavaScript modules by sheer volume of anybody on the planet. He writes modules all day. He's a big member of the Node community. And he also used to build underwater 3D robots in Alaska. So he has this kind of crazy other skill set that also happens to be useful when doing 3D math and games and things. So I was like, Substack, can you help me write this library? And so together, we stayed up till like 3 a.m. a couple nights in a row. He kept coding until 8 a.m. I woke up, got a bunch of pull requests from him, and we had Voxel.js. And then since then, people have built some really amazing stuff. There's some core modules that Substack and I collaborated on, and then now there's all these third-party plugins. And most of these are written by people that I don't even know. They just see the project online and they start and get involved. It's really fun. It's a good way to waste a weekend or a month, or in my case, 6 months. So I wrote a blog post if you want a little bit more of the background story of the project. I don't have time to do the full thing here, but hopefully it loads. It's basically, the blog post talks about the very early days of the project, which is only back in January. So how did we go about doing it? And why did we use Node? This is all in the browser and it's 3D. Node is a server-side thing that has no graphics. So let me talk about that for a second. One of the best parts about Node is that, actually, let me not go to that one first, but go to this one, the package manager. So NPM is basically, in my opinion, the best place to put JavaScript code. Doesn't matter if it's going to run in Node, doesn't matter if it's going to run in Chrome, Firefox, BlackBerry. If it's JavaScript, heck, if it's anything that you want versions and anything that you want to have dependencies and you don't want to worry about going to jQuery.com, downloading jQuery.1.7.1.min, go into your downloads folder, drag and dropping it into your project folder, going and adding a script tag, all of that manual stuff, and hoping that jQuery 1.7.1.min doesn't break your jQuery plugin, having to deal with all that stuff manually is really annoying, and NPM kind of solves that problem generally. So I decided NPM has awesome tooling. It works with JavaScript. Let's put all of these 3D game components on NPM. And instead of having one giant repo called Voxel.js that has a lib folder with 97 subdirectories, let's just make 97 node modules and put them on NPM. So if you go to NPM and you search for Voxel, you'll see pages and pages of Voxel modules now. And it's kind of cool. The community came up with this pattern where you prefix voxel dash, and then you write your plugin. And so then people looking for other modules that work with the game, they can go to NPM and search for Voxel, and it'll come up with all the Voxel modules. So we kind of have our own namespace within NPM that's specifically for Minecraft-esque 3D games. And it also branched out. So there's other modules in here that have nothing to do with Minecraft necessarily, but they're more useful for first-person shooters or 3D physics. So it's been a really vibrant project, and we basically piggybacked on NPM because it's the best way to get version code programmatically installed and have people collaborate on code together. The other cool thing about Node is that it's a really good way to write fast JavaScript. I've been working on this short ebook kind of thing called The Art of Node, which is basically everything I've learned from the Node project and how it applies to JavaScript and programming in general. Because there's a lot of misconceptions about Node. It's like, is Node just faster Rails? Is a question I hear surprisingly a lot, and they have nothing to do with each other. So this is a question at the heart of the Node project, which is like, why is Node popular? And Node has certain values, like things should be fast, things should be streams. There's a lot of parallels between the Unix community and Node, and those things happen to be very important for games. You don't want to have to wait half an hour for a game to load. When you go from one level to another, it would be nice if it was just seamlessly loading between the two and you didn't have to wait for a loading screen. When you load the page, you don't want to wait for all the assets to load before the game shows up. The game should just show up and the assets should stream in. So Evented.io is really important for making fast web game experiences. Oops, let me get on the right side of the presentation. So the way that you use Node modules in the browser is this thing called browserify. And basically, Node modules are just, there's a JSON metadata and then some code. And the JSON says, here's what this code depends on, and here's what version this code is at. And so what browserify does is it lets you write code with requires. So you can require modules, and then you say, okay, browserify this file, and what browserify does is it goes out, it gets all the modules that are required, it goes into those and says, do you need to require any subdependencies? And it goes through all the dependency graph. It combines all the modules into one file, and it sends that file to the browser, and the browser runs it. So it's basically a way of making bundles out of code, and you use NPM to install modules. So it's really awesome because you can say npm install foo, foo will get installed. You can make a file, say require foo, and then foo will get combined with your file into one bundle and sent down. In this demo, there are 72 modules, I think, and they all get required when the browser refreshes. So we have a development server that was created by one of the Voxel.js contributors called Beefy. And Beefy is kind of like browserify, BFY, like there's a pun in there somewhere. But Beefy essentially is a server you run. It's a static file server, but every time it hits your main program, it browserifies it on the fly and serves it. So every time you refresh the page, you get a new bundle. So you can change all your modules, and then every time you refresh, you get the latest code. And that way, you don't have to have like 97 script tags, or you don't have to wait for like 50 XHR requests to happen. You just get the one file sent down. It's kind of like a compilation step. But it makes it really easy to work with browserify. As an example, there is... if I do beefy index.js, or actually let me do npm start, address in use. Aha, it's already running. So when you run beefy, it basically runs on a port, and then when you request the page, then you'll see the static file requests coming in. And if it's purple, it means it's a dynamic request. So instead of serving bundle.js, it actually browserified and sent back the bundle. But for all the other things, it serves static files. And then what you end up with is this presentation. And the presentation code actually looks like awesome WebGL bug. The presentation code looks like this, where here's all the URLs for my slides, and then there's code that requires things. And require doesn't exist in JavaScript, but it does exist in Node. And basically, all browserify does is it makes sure that when I require the Minecraft skin module, which makes this little guy show up, that the Minecraft skin module is in that bundle before this code runs, so that when this code runs, require actually requires the Minecraft skin module in, and they're all combined into one package. So that's basically our collaboration workflow. Is we just use the same method that people that write Node modules use to publish things. We add require statements into our code. We use browserify. The other really important thing is, let me find, I think it's, let me build a little tower here to get up there. Okay, so, oops, too high. Now I'm flying. Okay, so we have a community standard now that there should only be 2 steps to get a project to run after you clone it. You clone the Git repo, you type install, which installs all the dependencies. That's a standard npm commands. Then you type npm start. That should be the learning curve for any npm module. In general, we try to make it the learning curve for all the Voxel.js modules. So if you see a really cool thing, you want to run the demo, you clone it, you type install, you type start. That should open up the demo. That should either start the development server or like give you instructions, go to localhost 8080 after you type npm start. And then if you ever have to do anything more than that, that's making your open source project too hard to use. You're not going to get as many pull requests. You're not going to get as much engagement from people. So we realized, and by we I say all the people that are writing Voxel.js modules, that making it super easy to get things to install is very important for growing the community. The actual, did I forget one down there? Oh, I restarted, so I lost some of the slides, but whatever. So this is what the actual core engine looks like. We have a pretty extensive README that has kind of, the meta stuff, like here's what this is about, here's kind of like the background information, then it gets down to actual documentation function by function. And this grew over time. I got a lot of pull requests to just the README. I also got a lot of pull requests to the code itself. But the goal here is to make something that's easier to express yourself in than Minecraft. So the way that Minecraft works is it's closed source. It's written in Java. So to write a plugin, you have to decompile Java, and there's people that make decompilers. But if Minecraft, they don't have an API, so if they upgrade the version of the Minecraft client, it means that now everybody's plugins are broken. So then the person that decompiles, he has to decompile it, write a new decompilation-based API. It's totally insane. It's basically like the most developer-adverse way you could try to get engagement. But because Minecraft is so fun, people are masochistic and they do it anyway because it's worth it. So I figured hey, this is the web, this is Node. These things are supposed to be fun and fast and easy. let's try to make a better API for doing the kinds of things that Minecraft is possible in doing. So the first few months of the project were just like, oh, we have to implement all this crazy voxel rendering stuff. We have to do stuff like this. So like if you click on a block, it highlights red, which is kind of hard to see maybe here. But then if you hold down Shift, or if you click, it removes a block. If you hold down Control, it places a block. And if you're on top of a block and you hit Control, it puts a little wireframe of where it's going to place the block before it places. And like little things like that. If you hit R, it goes to third-person mode. And if you jump, you can jump on top of blocks, and you can see your own face when you look down, and you can build towers, and all sorts of this stuff. And then another module that I wrote is like if you double tap, you go into fly mode, and you can fly around. And then it's just like each one of those things that I just showed you. The highlight thing is a module. The block placement is a module. The fly stuff is a module. The Minecraft player is a module. Doing this. Doing that is like 4 modules, because we have like a gravity module, we have a physics module, we have Newtonian physics now. Like people have gone crazy, because what I did was basically, I made the core thing that everybody can plug into. And then I said, hey, use NPM and stake your claim on whatever you want to work on that's part of this ecosystem. So instead of spending a year and doing everything myself and making a giant game framework, which there's plenty of those, I think we spent a week and a half making the first version of Voxel.js. And then since then, we've received probably 100 modules from the community, from like 20 or 25 different module authors. And then a bunch more people that are writing apps based on those now. So it's been really fun to work on, because every day there's new pull requests. The community is really awesome. We have an IRC room, Voxel.js, that, this is a discussion that was happening earlier. I wish I knew a better way to do incremental in-place topology modifications on simplicial complexes. It's just like, every day I read IRC, my mind expands and I learn a new thing, because there's a really awesome community that was looking for an outlet that was more rewarding than, Minecraft updated and I have to spend 2 weeks fixing my hacked plugin. So we were working, it was pretty developer focused, and some of the things we realized was that things like, if I depend on somebody's module and they upgrade their module and then it breaks my code, I get mad at them. And there's actually a versioning semantic, semantic versioning, and it's a versioning semantic for your modules. So if your module is 0.0.1, 0.0.1, and then you fix a bug, you're supposed to upgrade it to 0.0.2. But if you add a new feature, you're supposed to upgrade it to 0.1.0. But if you break a feature, you're supposed to do 1.0.0. So it's like this is how Semver works, but people didn't get that. It was never explained to them. So Dominic Tarr and I have made this when we were both in New Zealand, and we were talking about, isn't it annoying when people don't do versions correctly? Because if you rely on somebody's module, you want to know when their module is going to break your code. And if people do Semver correctly, then it helps everybody. So we made this little page, Semver for the win, use it correctly, and everybody's happier. Things like that are basically, the community needed to have some sort of guideline or help to understand how to collaborate better. And a lot of this comes down to, it's people. You have to be nice in pull requests. I think if you grepped all the pull requests for all the voxel modules and looked for did a sentiment analysis, you would find them to be overwhelmingly positive. Most of them have thank you and exclamation points all over the place, because working on this stuff is really fun. And when somebody builds an awesome piece of 3D functionality and sends it to you, you're not going to complain that they didn't use the same semicolon style as you. I want to give them a hug, and then behind their back, I'll change it to my semicolon style, but not complain, So it's the style needs to go away, and people just need to celebrate contributions in whatever form they come in, as long as they pass the test suite. So for a while, we were kind of working ad hoc, and I put together this document, which is kind of, from a programmer standpoint, how to write a Node module. And it goes through step-by-step authoring a module. And it talks about, here's what Node is, how do you install Node, here's how to make a new project and use NPM, and here's how to actually hook into the game. This is a module that builds a tower of blocks whenever you click. And the core part of the module is the place function, which does a for loop for a certain height, and then just does set block at a position that's y times the height. So if you do a thing 5 blocks high, this will get called, and y will be 1, 2, 3, 4, and 5. So it'll just do a loop and set a bunch of blocks on top of each other. So that was the simplest possible module I could imagine. And then it talks about, here's how you package it in a way that people can run the demo really easily. And then it also talks about how to publish on NPM, how to get Beefy installed so you can have the nice developer workflow where every time you refresh, your new code is loaded into the page, how to write a good README, how to maintain, and then basically everything that I learned in the first few months of managing projects and linking everything together. And this is so heavily based on basically what GitHub and NPM offer. It's crazy. Like without GitHub and NPM, this would not be possible, this kind of workflow. But I think this is a really interesting way to develop software where it's radically open in the sense that we're embracing the social side of things really aggressively. So it was developer-oriented, and I didn't like that because Minecraft is for kids, right? And all I had was a bunch of like adult game developers contributing code, but there wasn't a lot of kids contributing things yet. So hopefully this loads all the way. My girlfriend was working at a company called DIY.org, and they're for kids. They teach kids how to be hackers and makers and to do things themselves. And so I made this app based on a thing that I saw Mr. Doob did once. I rewrote it and made it more kid-friendly. And does anybody know the Spore Critter creator? Has anybody made the creatures in Spore? It's like before Spore came out, the Critter creator went totally viral. And then when Spore came out, everybody was like, oh, if only Spore was as good as the Critter creator was. So I was like, the Critter creator was awesome. I wanted to make like a voxel critter creator. So I wrote this app. This doesn't actually use Voxel.js. It just uses Canvas and fakes 3D, which is one thing 3JS lets you do. So you can basically place blocks. You can look around and rotate the scene. You can turn off and on the different aspects of the rendering, and you could pick different colors. So it's really simple primitives. You can like hold down Shift and it'll delete. You can hold down Alt and it does like a bulk draw. And I'm not a very good artist, but what I found out was that there are a lot of really good artists on DIY and recently made critters. So this is all stuff that kids have made with this tool in the last month or two. This is my favorite. So this kid said it took him 3 hours and he implemented this Mario just from like freehand in this tool. Made this 3D Mario. And there's other really crazy ones, like there's like a fractal castle design down here, if I can find it. Yeah, this thing's really cool. Just stuff that blows my mind, the amount of complexity. And like the app kind of gets slow when you put a lot of blocks, but the kids didn't care because they said it was fun. And because this doesn't use Voxel.js or WebGL, it can be kind of slow when you do a really big thing, but you know, it didn't really matter. And I got to play with fun technologies while building this. I got to play with working on my UI stuff. I was using the flat UI thing because I thought it looked cool and it had bright colors and was kid-friendly. I got to do a lot of stuff with actually cryptography and stenography. So when you export a PNG, what happens is it creates this screenshot. But this screenshot in the RGB channel of the PNG, I've encoded the voxel data so you can reconstruct the 3D geometry from the PNG. So all I do is I load the PNG back into the editor, wherever it went. And so this 3D model was reconstructed just from loading the PNG into a canvas and reading the pixel data and grabbing a bit mask off of that. And I learned that method from a Voxel.js contributor who happened to study stenography in college and wrote a module for it. And so it's just like 6 months later, and I'm still working on this stuff, and every day I'm excited to get up and see what pull requests I got sent today, you know. It's a super rewarding project. So that was my intent. My intent with that was to make another way to contribute. If you're not a coder at all, you can still express yourself kind of in a 3D design capacity. Another thing that I did, I realized that command line is kind of a lot to ask of people, especially if they're not comfortable with coding, but even if they're not comfortable with Node, it's a little bit of a steep learning curve. It's relatively easy, but still you have to be comfortable with the command line. So I decided, let's make a web browser-based editor. And this is like the code mirror editor, and it's hooked up to a server that I wrote that basically just, you send it your code, and it browserifies it and gives you back the bundle. So if you hit play, it'll go to the server, bundle it, and then run your game immediately. So it's kind of like a Voxel.js REPL, sort of. And there are some really cool things that people have made with this. Let me go to this one. There's this format called the STL, which is like the CSV for 3D objects. And this demo, wherever it comes in, it has to load over the network, so it might take a second. This is a giant face. And what it does is it's sideways. But the face loads in, and then it gets voxelized, which basically means it's like to pixelate in 3D. And so you can import objects into here. And this one doesn't preserve coloring because it's a really early version, but basically it would be really cool if you could import 3D models into Voxel.js and then kind of Google Doc style, collaborate on them, and then export them out in 3D print them. And people are working on that kind of stuff now. There's a module that takes a Voxel.js scene and uploads it to Shapeways, which is a cloud print service. So you could print it out in different materials and get it mailed to you. And there's another one that's really awesome. I think is this one. So this guy got on the IRC channel and he was like, I'm really into, he was like asking all these technical questions. He actually built a module that fractally generates a castle in Voxel.js based on a thing called L systems that I had no idea existed. It's like a mathematical fractal expression language, and he was procedurally generating castles with it, but he implemented all of Tetris. So this is a full Tetris game, and you can click over here and it goes right. You can click on it and it'll rotate. You can click down and it'll snap down to the bottom. And then, you know, it's super awesome. He also realized that wouldn't it be fun if you turn the gravity really low, you could jump up on top of the blocks. And let me wait for the next one. So you could basically you could play Tetris from above. Now I'm like totally running into it. But this was just like one of those things that blew my mind. He also hooked up, there's a 3D positional audio API in Voxel.js. And, well, you can only hear it on my computer, but the Tetris theme plays when you get close to it. So somebody actually wrote a module that you could have sound emanating in 3D from a position, which is supported by the Web Audio API, which is the new thing in HTML5. So basically, you could have sounds coming positionally, and then he made it so that if you build a wall, the sound doesn't travel through the wall. So it knows line of sight, basically, and you can hear audio, like realistic 3D audio, which is pretty cool. So that, you know, I get my mind blown all the time by awesome things that people have made. So I just wanted to show some demos that are exceptionally mind-blowing. But let me start. Okay, I'll just go in order. So this is actually a thing that I made a couple weeks ago because somebody asked me to make a stop-motion tool. And so this is called GIF blocks. Basically, the way it works is there's a camera over here, and the camera is looking at a certain point, but you can fly around and you can say, okay, I want the camera to now look over here, and then I'm going to take a picture. You hit enter, and then you can delete some stuff. You can switch to different materials. You can build a little thing, and then you can move the camera, and then you can take another picture, and then you can go down in there. You can say like, hello, camera. There's my face, and then you can get it from another angle, and then basically do a little stop motion studio. Then when you hit export GIF, then I think I hit it. Then it makes you an animated GIF of your movie. So I wrote this as a little prototype. I haven't got it into DIY yet, so I really am excited to see what movies kids make. Because I remember when I was little, my favorite thing was taking a digital camera, which was like brand new technology in the 90s, and making little stop motion movies. Or I think I didn't even have digital cameras. It was like VHS, where you take like half-second camcorder things and made movies out of that. So that's like straight from my childhood, trying to recreate in here. And then there's also, this is one of the earliest things that I got that somebody made totally independently. There's all these events. Felix, who spoke yesterday, or I don't know if he spoke yet or whatever. Anyway, Felix is awesome. And he started this thing called Nodecopter. And Nodecopter, my computer's chugging, so I can't jump up. There we go. Nodecopter is basically programming flying helicopters with Node.js, making it really easy for people who have no programming or helicopter flight experience to write little copter things. And this is an emulator, a full emulator for that. So you can take off, and then it takes off. And you can look at yourself in the camera. You know, there's the little guy. And you can use it actually. So the cool thing about this shows the power of browserify. There's a module called AR drone on NPM, and it's like it uses UDP. It talks to the helicopter, but instead of UDP, we require the AR drone module, and we instead use the exact same JavaScript library that controls the library, the flying helicopter. We use that library to send commands to our virtual drone. So we have like a UDP to drone thing. But you use the exact same script. So it's a total emulator, and it's running the exact same code. So you can say like up at a speed, and you can say right at a speed, and you can say clockwise at a speed. And then now the drone is going in a figure eight kind of, or like a corkscrew. And you can say lands. And so I've heard a lot of people, they use this when they're testing out their scripts because the drone runs out of batteries, but this one doesn't. So it's been really cool to see, oh, that's why it's slow. I had this one running in the background. It's been really cool to kind of blur the gap between virtual and hardware. And I want to have like a real-time thing where the drone, you can control the drone in here and it's sending commands through Node to the actual copter. No, I haven't seen anybody do that yet. And then, what is that one? Oh yeah, this is super awesome. So this is a guy who wrote a Node. He was working on a Node bot for Minecraft to do things like when he goes and eats dinner, the bot can be scripted to go and dig for gold, and like a gold farming bot. So he already had Node talking to Minecraft servers. So he basically wrote a Voxel.js client that shows where the bot is in Minecraft. And so this is like the actual Minecraft client, and this is what the bot sees. And this was one of the earliest things where I was like, oh, I should start actually implementing Minecraft. So to implement Minecraft, you have to do a few things. Like I started implementing the player skin. So I found online somebody that had done it, and I turned it into a module. And basically, you load in this map into a canvas, and you just read out the certain areas and apply them to a 3D geometry. And doing that as an experiment, that's the kind of stuff that's really fun to get your feet wet doing 3D. Then another thing you have to do is Minecraft has like, you know, the whole crafting UI. So somebody actually has a module that you can do real crafting. So if I take some wood, and then I get some sticks, and then I put my wood back down here, and then I take my sticks and I put some diamonds on it, then I can get a diamond shovel. You know, like this is how Minecraft works. All the recipes for Minecraft are loaded in as JSON. You could also define your own recipes. And, you know, it's crazy. Minecraft has such a cult following that people freak out when they add new 16x16 block textures. Like they added quartz textures, which is like literally a 16x16 texture, and like the world went crazy. And now kids are thinking it's the coolest thing ever, and all they did was go into Photoshop and made a 16x16 texture. And it's just like testament to how exciting Minecraft can be, even though Minecraft hasn't really changed in the last year. So I'm hoping that our project catches up and surpasses Minecraft soon, but still we're lagging behind. But stuff like this is coming out all the time, and people are figuring out ways of doing what Minecraft does, but in a more hackable way and in a way that's more fun and better because you can understand it and you can configure it. So another aspect of Voxel.js is that you don't necessarily have to do Minecraft. This is actually, this guy has one of those grid button music controllers that lights up when you press the buttons. And we were sitting there, and he was like, this thing kind of looks like voxels. And I was like, yeah. And he's like, they're RGB, and you can control them with Node. There's a Node library. So he wrote this. This is 3D Voxel.js like VJ software for visualization. And he's playing a song on his controller, and it's showing the buttons that he's pressing in kind of like an abstract way in Voxel.js, where he just made everything black, and then he made a bunch of neon textures that light up. And I was like, that's so cool, because I had no idea that anybody could do music visualization software with it. And then somebody else the other day made this, which is called Archive Room, which is, you can go here, it's archiveroom.net, and you can basically explore one of your GitHub repos in Voxel.js, kind of like, like my favorite movie is that movie Hackers from the 90s. This is totally Hackers. It's like you're flying through columns of code commits, and it's kind of like a data viz tool, essentially. So this is a pretty cool little project that you can check out. And then this is a demo that I did for this thing called the Ludum Dare, which is a 48-hour game contest. And the point of Ludum Dare is you start with no code, you can use libraries, and then in 48 hours you're supposed to build something cool. So Rob, who just talked about WebRTC, it was awesome to hear about that because this uses WebRTC. Let me just open this up in a couple tabs. Here we go. So what it does is there's a, well, let me just play it and then I'll explain it after this guy loads. Find an opponent. Now I'm playing against myself. So there's this little arena, and if I go over with this guy, this is fully peer-to-peer. So there was a lobby server, and when you're the screen just before this, you basically both browsers, everybody connects up to a WebSocket server, and then it just pairs people off. Then once they connect to each other, then they disconnect from the WebSocket server, and then all the gameplay is actually totally peer-to-peer. So when I move around on one screen, it's sending UDP messages through WebRTC to the other guy. But because right now WebRTC isn't reliable to do this, there's a potential that I would lose blocks because messages wouldn't come through. So I just really simply just send the last 5 things that I did every time. So I send a little bit bigger messages, but that way if I lose some messages, it's likely that one of them will get through. So you can kind of have like a multiplayer Minecraft without running a server. So the point of this game is that there's these blocks up in the sky, and water will start falling from them. So what you're supposed to do is build blocks to make the water fall down, and whoever creates the most surface area, because once the water hits the ground, it'll disappear. Whoever creates the most surface area for the water to flow over will win, and it basically just does volume calculation of who did the best job of making the water spread around. But of course, you control the other player by like deleting their blocks. Where's my crosshair? And like removing their stuff at the last second. And each person has a spout, and the water comes out in different colors. You can play this. What it looks like is, What it looks like is, let me show you the GIF here. Probably get to it a little bit quicker. I load the full 3D scene in the background so that when you join, it's instant. It looks like this when you're playing, where it basically floods down, and then the green, in this case, would win because the blue guys just fell down into a hole. So you can play this. As was mentioned in the last talk, Chrome and Chrome will work fine together, but Chrome and Firefox won't. But Firefox and Firefox will. So until WebRTC stabilizes cross-browser, the data channels aren't cross-browser yet, but they do work. People have played it against each other in random opponents. That was super fun because the code to do that is pretty simple. There's the hardest thing was figuring out, okay, there's a server that does the game lobby stuff. Then there's a server that does the peer-to-peer connection stuff. And the peer-to-peer stuff was easy. There was node modules for that. And the game lobby was relatively easy, but having to do all those things in a 48-hour competition was pretty fun. And then the client looks like this. It's only 200 or 350 lines of code for the full game and all the logic and everything. And it was a super fun experiment to see, you know, can I do multiplayer without having to set up a server infrastructure? And then one of the other things I started doing was Minecraft has world files, and people share them online a lot. And so this is a New York City world file loaded in. But I have another more special thing to show you guys that I prepared. This is a project I've been working on. So building on the peer-to-peer stuff and building on the Minecraft emulation stuff, we got to a point in the rendering where we had to do things like this. Like this came out of the Voxel.js project. This is a dynamic bin packing atlas generation thing that uses a canvas and combines PNGs into one bigger PNG. You get the offsets. If anybody's ever made a sprite, it's basically the same thing. But we had to do this to reduce the number of draw calls or 3D rendering calls in our game. So all the textures get combined into one of these when the game loads, and then it just has one texture that it has to buffer on the graphics card. And so we've been working on rendering, and rendering's good enough now that we can render full Minecraft levels. So if I go to the local server, so I'm working on this app, and I thought it was funny. The last 3 speakers previous, I'm using all the technologies that they talked about in this demo. So this is a hoodie app, which is Jan's thing, and just because I hate writing login, logout, authentication stuff. So if I log in as the test user here, the goal of this is that I want to have kids be able to share the worlds from their Minecraft saves folder online, and then let them play 2-player for free with their friends. And then also have it so that because Minecraft files are a bunch of individual files and they can be really big, people have to use Mediafire to share them. You could just have a website that's kind of like GitHub, where you can post your Minecraft world and people can download it and make edits and send you edits back. And you can start to collaborate on 3D stuff. Because like what I was talking about earlier with importing 3D models and 3D printing them, it'd be really cool to have more granularity than taking a screenshot of the thing you made in Minecraft and posting it on the Minecraft subreddit. You can't take a screenshot and load it back into Minecraft unless you do the stenography trick that I figured out. But Minecraft doesn't have that yet. So if you create a world in here, I have an option to import an existing Minecraft file. And I found this awesome map. So this is actually a stream now. So I think there's 7 modules that I wrote for Minecraft file parsing, because there's all these different aspects. It's a binary file format. It involves zlib deflating. It involves reading byte offsets. It involves parsing different coordinate systems. And there's 33 million voxels per Minecraft file. So this is now, this green bar, when it fills up, it means it has parsed all 33 million of them. It saves them into IndexedDB through a project that I did called Level.js, which I think is here. Level.js, maybe it's a dot. Oh yeah. So Level.js is like a binary data store for the browser, because IndexedDB lets you store binary objects like array buffers and typed arrays. And so what this does is it reads all 33 million voxels, splits them up into little chunks like map tiles, and then compresses them using a run-length encoder that the math PhD, who was aforementioned, wrote. Takes the run-length encoded typed array, stores it in IndexedDB, and then does that, I think, 4,000 times. So once this loads, the full Minecraft world will be loaded into the browser's database, and you can play offline as long as you want. The next step is that I want to sync these up to a hosted backend so that when people browse to your, basically like the equivalent of your Minecraft repo, when people browse there, they can sync the binary data down to their IndexedDB, and then they can play offline. Then you can play against each other, two-player, multiplayer. And so this was super fun because I hadn't had an excuse to do real like low-level binary parsing and doing an efficient streaming parser. So I'm doing things like yesterday I added a web worker so that you can still like do math in here. Before what I was doing is this was such a CPU-intensive operation, parsing millions of voxels out of a binary file, that it would block the CPU until it was all done and the browser tab was just sitting there doing nothing. So you know how I mentioned that there are a bunch of textures? So you saw just now that the textures turned on. So it takes a second to download all the textures, but it doesn't block the game from loading. And then if I go over here, I'm not using a worker right now to load the chunks, but I could. I just haven't written that yet. So when you cross a boundary, there's a little bit of lag because it's doing it on the main thread in JS. So this is an actual Minecraft level straight out of the Minecraft client. And I'm in a fjord. And this is a fjord reconstruction that some Minecraft player did. And then there's this awesome Minecraft Viking ship. And I wrote a module that has all 400 Minecraft textures. So it's pretty close. You'll notice that you can see the boundaries where my water overlaps. I need to fix that issue, but there's, it's getting there. But once you're in a chunk, I'm running here at about 30 frames a second, but that's also because I have another voxel game running in this tab, which I will close, and then the frame rate should get better. But this is a Viking ship in a fjord rendered from a Minecraft world, and let me open it up in real Minecraft so we can kind of see the difference. I have the same level loaded. And let's see. The Minecraft client here. This is like the Java implemented one that you buy for like $30 or whatever. So if I log into the fjord in here, here is the Minecraft version. Where I hope I can fly. Yeah, there we go. So here's the Minecraft ship within the fjord, and then here's the Voxel.js ship in the fjord. So I'm getting there. There's some things that Minecraft does better, like its lighting system is better. But there are certain things, like Minecraft's anti-aliasing is weird. Like off in the distance, it has this kind of weird speckly pattern. It does a lot of like level of detail stuff to render more terrain, and I'm not doing that yet. Which makes the stuff here look a lot more crisp. And I also don't have like the draw distance turned on as high. But the goal is to make it so you can play Minecraft for free in the browser and collaborate and share your worlds, because the things that I've seen kids do with Minecraft is totally mind-blowing. So I kind of just wanted to support that. So the Blockplot project is not launched yet. I'm still working on it, but you can go there and sign up or whatever. Follow the Voxel.js Twitter account to get more info on that. And a lot of projects that I see, they have or a lot of slide decks. They have like a how to contribute thing at the end. And basically this whole talk has been a how to contribute thing. Dominic, who spoke earlier, he jokes that if he's scared to contribute to this because he knows it will take up 6 months of his life. And we've had little conversations when we see each other like, hey Dominic, how about writing like a mesh networking layer so we can have like massively multi peer-to-peer connections? And he's like, that's tempting, but I know that I won't do anything else for months and months and months. So if you too want to waste your weekends building 3D games to make kids be able to be more creative, then get involved with the Voxel.js community. There's, like I said, there's 100 plus modules now. And each one has a repo, and each one's on NPM. So there's lots of ways to get involved. I think that's everything I had to talk about. So thank you. Yeah. Alrighty, and questions? I see one over here.
What do you feel is the real takeaway from this? Is it to build Minecraft in a browser, or how to really create a project that gets a lot of attention and get a lot of pull requests and a lot of extra modules?
So the takeaway for me, at the beginning, I wanted to play with 3D. And I did it the way that I knew how to do it, which was have a project be open from the beginning. And then, because it was Minecraft and it was the internet, it got really popular. Then I was like, wow, people want to do this. So then it became more of a, let's start building out all of Minecraft piece by piece. That came later. The original goal was just to make another project and to screw around and see if anybody was interested. And then what I learned along the way was kind of how to manage a large project where where it's super flat, where there's not, the biggest module is 400 lines or 600 lines in this all of the 100 of modules. But together it's like 5,000 lines of code, roughly per app, because of all the modules that are used. If you look at all the physics modules and all the texturing modules and all the rendering modules, when you combine them all together, you get, 5,000 lines of code, but each one is 100 lines, 200 lines, 400 lines. Each one's in a different style. Each one's in a different repo, but they all work together because we all agreed on simple protocols and APIs. So I definitely learned a lot. I'm definitely a better developer, and at the very lowest level, I understand why I should have taken linear algebra in school now, because of graphics cards and how awesome they are.
Thanks for a great talk.
Oh, yeah.
It's really inspiring to see open source at work like this with all the pull requests and stuff.
Yeah.
I was wondering, that demo you had before with the Kids app where they can build the blocks, did you actually store the data for the model in the URL?
Yes, that also. Yeah, so there was like a query string so you could tweet out, and it totally abuses query string limits, but I think in Chrome it's like 4096 characters or something. But you definitely get in voxelbuilder.com, you have these really long URLs that are, it's like an equivalent of base64 encoding the voxel data. So it encodes the data in the URL and also in the PNG. Other questions? Oh, here we go.
Hi there. You briefly mentioned NPM and Beefy that you use to load the modules. Do you have any feelings about how that compares to AMD and something like Require.js? Why did you go for one, not the other?
Oh, yeah. So I wanted something that worked with NPM because of all the package managers I've ever used, NPM is the one that's the most rewarding in its simplicity. It's easy to publish, it's easy to install, and it makes sense. I haven't found a package manager that is more elegant and simple than NPM for the core use case. So that was my main thing, was I wanted something that worked well with NPM, and browserify naturally works with NPM. I've looked at most of the package managers and most of the build tools, and they all seem to be reinventing a lot of the parts of what NPM and browserify do without getting the best parts, in my opinion. So a lot of them are really complex. I didn't like AMD because it was the syntax was really verbose, and the documentation confused me every time I read it. And it's ironic that Require.js, for instance, doesn't use the simple require style from Node. And for a long time, I tried to do no build step kind of development. But, if you try to load 100 modules into a page, even in development, it's going to take 30 seconds. So having Node sit there and serving my bundles for me makes it a lot easier to install stuff. And basically, the main thing was that I wanted to be able to publish to NPM and install other people's modules from NPM and let NPM handle all the grunt work. And I also don't like buying into complex build frameworks. So there's like 10 frameworks and like 4 package managers that have launched that are targeted at client-side developers. And I think that they're betting on the fact that people think that NPM is only for Node. But if you look closely at the NPM.js website, to dispel the myth that NPM is only useful for Node, it says Node packaged modules, which just means that Node packages them. It doesn't mean that they're for Node. So I actually have a module on NPM that's Java for Android, because I was just screwing around with programmatically installing Xcode plugins, or Android plugins. So you can use NPM, you can put anything on there. It also stores arbitrary binary attachments. So you could put whatever you wanted on NPM as long as there's a package JSON file that specifies a version. So I think that the idea that NPM is only for Node people it's kind of like, it's an unfortunate misconception. Because I think it's the simplest and most useful tool.
Okay, so you get to pick who gets the phone.
I like the package manager question.
Well, thank you.